All right, we are on to the last section of EE 220, which is circuits in practice. This is going to be a section where I talk about components, resistors, capacitors, inductors, active circuits like we've talked about. And I'm going to kind of just overview how what they look like in real life, how circuit boards are manufactured, how integrated circuits are designed, and how it all comes together, is manufactured, and so on. I think this is really important stuff. It's really good to have a little bit of a grasp on this stuff going into the future of your EE classes. Really brings the stuff to life, in my opinion, and I wish I had learned this stuff earlier. So that's why I'm teaching it to you at the end of EE 220, because a lot of students get through their entire degree and actually never learn a lot of this stuff, which I think is really upsetting. So let's get right into it. So I have this little table here, which I think is really cool. Basically, I have the component name on this as the columns. So I've got resistors here, capacitors here, and inductors here. And then going down the rows, I'm first showing the symbol for that component. So let's just look at resistors for now. We'll just block it off and just take a peek at this resistors column. And so this is obviously the symbol for the resistor, which we've seen all throughout this class. And then there are two different types of components that you'll see when it comes to actually building electronics in real life. There are surface mount components, SMT, or sometimes you'll see SMD. I think surface mount device is SMD and surface mount technology is SMT. Either way, SM is the key. It's surface mount. What does that even mean? Well, if I have my circuit board, so let's say I'm looking at a circuit board. Actually, let's look at a circuit board from the side view. If I'm looking at my circuit board from the side view, if I take my surface mount component and put it on the board, it's going to sit right on top of the board just like this. And from a three-dimensional view, let me make this a little bit more 3D here. If this was a three-dimensional view, then my component would sit just like this, and we would be seeing the component sit right on top of the board. And in other words, it doesn't go through the board at all. It just sits right on top. I would have a pad, this would be my resistor here with that black part in the middle. And then I would have the two electrodes basically, which are, this electrode corresponds to that lead and this electrode corresponds to that lead. And then the resistive part is in the middle, right? That's where the resistor gets its symbol. And so that's the key for the the surface mount component, is that it sits on top of the board. If I have a through-hole component, this is also a resistor, right? This lead is that leg, and this leg is here, and then the resistive part is in the middle. And that component itself goes through the circuit board. So if I would have two holes in my circuit board, and I'd have the leg kind of going through the circuit board like this, and then my resistor would be sitting up here on the surface. But the legs would go down through the board, and then there would also be holes on the bottom of the board, and then so on. We haven't really learned about circuit boards. I'm going to get into that a little bit later, but I just wanted to make that distinction between surface mount and through hole. Really all it means is that the surface mount parts sit on the surface of the board, and the through hole parts go through the holes in the board. Pretty self-explanatory now that I repeat it. Okay, so we can see for the resistor, that's the case. For the capacitor, obviously we know what the symbol looks like. It's two plates separated by a dielectric. And so for the surface mount component, we can see there's a plate here, there's a plate here, and then this material in the middle is the dielectric. So that's this space in between the two plates. And this is the surface mount version of the capacitor. They come in all shapes and sizes, really mostly different sizes. Higher voltage capacitors are larger or are wider, smaller. You'll see really tiny capacitors that can only withstand 6 to 10 volts before they'll blow up. And then this is what a through-hole capacitor looks like. It's got the two legs, and then inside of the capacitor are the two plates. They're actually coiled up, where you have like one plate that looks like this and then another plate that kind of weaves inside the other one. And so you get the maximum overlap area, which is what gives us large capacitance, right? If we remember, C is equal to EA over D. And if we maximize that area of overlap and minimize the distance between them, then we can drive our capacitance way up. And so that's what they do inside of these electrolytic through-hole capacitors, okay? And then for the inductor, pretty straightforward. We know that it's just a coil wrapped around a magnetic core. And so we can see for the through-hole component, it's literally just a wire wrapped around a magnetic core. This is called a toroid. That shape, that circular shape is called a toroid. So that's a toroidal core. You also have just inductors that just wrap around a core like this, and then the core would be just a straight line, and that's fine too. But this is the one that I found online that had the nicest looking picture. And then this one right here is the surface mount version of it. You can see the wire wrapped around this middle section, and this middle section here is the magnetic core, all this black stuff that it's wrapped around. And then it has its little surface mount pads here, one here, and there's probably one on the other side so that it can mount right on top of the board, and it doesn't need to go through the board like this, like the through-hole version of it would, because those two wires would go through the PCB, the printed circuit board, and you would solder it to the board in order to make the connection. Okay, so this is just a practical look at some components. I'm going to go ahead and stop this video here. And then in the next video, I'm going to talk about integrated circuits, which is another type of component that is very widely used in pretty much any circuit you're ever going to see. Is going to contain some passive components and some integrated circuits, which are active components. Okay, so I'm going to go ahead and stop this video here.